I'm Warren Meyer and I run a climate site called climateskeptic.com. Just to answer questions early on, I have an equivalent climate degree to Al Gore's, which means I don't have one, but I did actually get A's in college, and I did actually study a technical degree. My degree is in mechanical and aerospace engineering, and my specialization was in control theory and the stability of dynamic systems, topics that tend to be at the very crux of the arguments for and against catastrophic man-made global warming. This presentation was written for the skeptic side of a number of debates I've participated in. Unfortunately, of late, I guess a lot of strong global warming advocates have taken Al Gore's lead and don't debate anymore. So I'm going to have to do their part too. I'll begin by quickly presenting the case for catastrophic global warming, and then I'll talk about the science behind the skeptic's position of why man-made warming almost certainly will not be catastrophic. The word catastrophic is important. It is why I've labeled this presentation Catastrophe Denied. That's because we're talking about not just global warming theory, that name is incomplete. We're talking about catastrophic, man-made global warming theory. All three of those pieces matter. A lot of skeptics have been positioned as deniers, mainly because that name evokes the term Holocaust deniers. Using this term helps position skeptics as somehow beyond the pale of civilized society, espousing views that aren't really fit to be listened to, or as some have suggested, don't even qualify for First Amendment speech protections. It is a way of avoiding actually addressing skeptics' arguments and pigeonholing skeptics as folks whose views don't need to be examined. But really, to the extent that I'm a denier, I don't deny that the world has warmed over the last 150 years. I don't even deny that man may be helping contribute incrementally to that warming. What I deny is the catastrophe. And so in this presentation we'll see that yes, there has been some warming over the past century or so. And yes, man-made greenhouse gases may have contributed somewhat to this warming. But man-made greenhouse gas warming is likely to remain at trivial levels, less than 1 degree Celsius over the next century. By the way, I know that global warming has been rebranded as climate change, but marketing is not science, and the warming matters. We're going to talk about it later, but recognize that no human being that I know of has ever suggested a method whereby CO2 causes climate change except via warming. If we don't see the warming from greenhouse gases, then we aren't causing climate change from CO2. So let's talk about the case for global warming. For those of you who don't know the basics, I'm going to talk about CO2 and how it can cause warming. We're going to talk about how scientists reach catastrophic temperature forecasts, and then we're going to talk about other climate changes that may or may not result from such warming. The little thing in the upper left with the C's and H's connected is a representation of a hydrocarbon molecule. Almost everything we combust for fuel is a hydrocarbon. The natural gas that we use out of the pipeline is one carbon with 4 hydrogens. Coal is a whole bunch of carbons in a chain with the hydrogens attached, and gasoline and liquid fuels are somewhere in the middle of that. Combustion is a process of breaking up these molecules into their component hydrogen and carbon atoms, and then combining these with oxygen. Hydrogen combines with oxygen to make H2O, or water, and carbon combines with oxygen to make CO2, or carbon dioxide. And of course, this combustion process produces heat because that's the whole point of it. We want to get useful work out of the combustion. By the way, there's really no difference between this and what goes on in your body when we metabolize food. It's the same basic process. That's why your body breathes in oxygen, expels CO2, and produces heat, because basically it's a kind of combustion in your body from the hydrocarbons in your food. The last few days, the EPA has officially named CO2 a pollutant under the Clean Air Act. But CO2 is different from most things that we've called pollutants in the past, because these other pollutants were not necessarily inherent to the fossil fuel combustion. The Clean Air Act was aimed at things like sulfur dioxide and nitrous oxide and ash from smokestack emissions. These were pollutants that resulted from impurities in the fuel or from inefficiencies in the combustion process itself. But CO2 is different from all these other pollutants because all those other compounds are ancillary or accidental. They're not fundamental to the basic combustion process. But CO2 is fundamental to hydrocarbon combustion. Unlike other substances we could filter or design around, the only way not to produce CO2 is to not have combustion. And that's why reduction of CO2 is orders of magnitude more difficult than was elimination of previous pollutants that we've tackled. So what is the greenhouse effect? I will try to explain quickly, and for those who really understand this, I already know I'm oversimplifying. Just bear with me. To begin the process, as you see here, the Earth is warmed by incoming radiation from the Sun. The Earth then re-radiates this as infrared energy back into space, as shown here, on many different wavelengths. These two sets of radiation, one into and the other out of the Earth, must roughly balance, because if they don't balance, the temperature of the Earth is going to evolve over time to make them balance. So think of temperature as always changing to try to force these two energy flows to match. If, for example, more radiative energy suddenly starts coming in than going out, the temperature is going to go up until the outgoing energy increases and brings the system back into balance. Now we add a layer CO2 to the atmosphere, which I've drawn in pink. CO2, like other greenhouse gases, absorbs some of the radiation that's going back into space. Not all of it, it only absorbs, as you can see in this picture, some of the frequencies. As you add more CO2, more of the radiation returning to space is absorbed. Eventually, though, the CO2 has a diminishing effect as its ability to absorb radiation becomes saturated in certain frequency bands. The analogy that is often used is like painting a window. You put one coat of paint on the window and a lot of light is blocked, but it's still translucent. You put another coat of paint on the window and there's still a little light that gets through, but you put a third coat of paint on it and nothing gets through. And then further coats of paint have no effect on the light transmission through the window because all the light is already blocked. CO2 is a little like that, working as a diminishing return. Later on, when we look at a curve of CO2 and its effect on temperature, you're going to see that CO2 that's already in the air has a bigger warming effect than CO2 that we'll add in the future. In other words, each additional molecule added has less effect than the last. Finally, CO2 re-radiates the energy it has absorbed. Some of it goes back into space where not much happens because that's where the energy was headed anyway in the first place. But some of this captured energy gets radiated back down to Earth. And so the effect of the warming comes because radiation that is leaving the Earth gets absorbed by the CO2 and some of it gets sent back down to the surface rather than continuing on into space. This becomes an additional energy flux or forcing on surface temperatures. And that's how CO2 or any other greenhouse gas works. This is a chart we're going to use quite a bit. It's simple, but I just want to make sure that we all understand how it's laid out, so I'm going to walk you through it in detail. The key question in climate is not whether CO2 causes warming. If you want to talk about settled science, and people really overuse that term, but the portion of anthropogenic global warming theory that really is fairly well settled, even to most skeptics, is that CO2 does cause some incremental warming. This can be demonstrated with careful experiments in the laboratory. Further, we know this to be true in a macro sense, as the Earth would be far cooler without greenhouse gases to make our climate more congenial. So CO2 certainly causes some warming. The question is, how much? Or more specifically, how much warming is caused by small changes in atmospheric concentrations of CO2? The CO2 concentration of an atmosphere right now is about 385 parts per million. On our graph, we will put the concentration of CO2 in the atmosphere on the bottom axis, running up to values of about 650 to 800 parts per million, which are estimates of possible atmospheric CO2 concentrations by the year 2100, presuming we do nothing legislatively to limit fossil fuel combustion. I think a lot of people struggle to visualize just how small 385 parts per million really is, so I'll demonstrate it with an example. 385 parts per million is the equivalent of 0.0385%. If you were going to fly from Los Angeles to New York, what would be the equivalent of 385 parts per million of that journey? In other words, what would you be flying over once you were 0.0385% of the way to New York? The answer is that you'd actually be only halfway down the runway at LAX. Hopefully that gives you an idea how small 385 parts per million really is. I should note that there are skeptics who do not think that man is actually increasing the CO2 in the atmosphere, that the increase is mainly occurring as a result of temperature increases rather than vice versa. Since I'm not an expert on the CO2 cycle, which is horrendously complex, I don't find this a very productive way to argue global warming. I will assume that most of the increases in CO2 are in fact anthropogenic or due to man. There are other lower hanging fruit than this in taking on catastrophic man-made global warming that I want to address. So back to our chart. We looked at CO2 concentration on the bottom axis, and on the left axis we'll put the global temperature increase expected for a given level of CO2. Often we will use something called temperature anomaly rather than an absolute temperature. Don't worry, the exact numbers don't matter as much as the changes over time. Besides, scientists actually have an easier time saying how much the world temperature have changed over the last 10 years than they have in actually saying what the Earth's average temperature actually is, or whether a global temperature even has any meaning in the first place. One way to think about it, scientists may not know what road they're driving on, but they can keep track of how far they've driven down that road. This formula is from several of the past IPCC reports. I believe it's originally attributable to a work published by Michael Mann in 1998. Since this is the first time I've mentioned the IPCC, I will give you a quick background on it. The The IPCC is a branch of the United Nations. It's a quasi-scientific, quasi-political organization that every 5 years puts out a report on climate change. These reports are monstrous, hundreds and hundreds of pages long, but only the summary for policymakers is really reported on very much. I won't delve too much in this presentation into the shortcomings of the IPCC process, but one interesting thing to remember is in the last IPCC report, number 4, the summary for policymakers was actually written first, mainly by political types rather than scientists, and then it was circulated with a note to scientists telling them to conform their sections to the summary. Anyway, back to the temperature projections. In the last several IPCC assessments, they said that if you look at CO2 without any other effects, without any complex interactions with the rest of the atmosphere, this is the formula that their best estimate of how global temperatures would vary with CO2 concentration. I know it's hard to have any real intuition about a formula this complex, so I've graphed it in blue. The IPCC says that as CO2 concentrations increase, assuming no feedback effects, which we'll come to in a moment, global temperatures should follow this blue line. As CO2 concentrations increase to 650 parts per million or more by the end of the century, from today's 385 parts per million, global temperatures would rise about 1 degree Celsius. Okay, I know what you're thinking. You're saying, Warren, you got to be BSing us now. You're not telling us the truth, because I know I've never seen a forecast as low as 1 degree for global warming. It's always 3 degrees or 5 degrees or 10 degrees. You've got to be missing something. And that's true. There is a second piece to this, and that piece is feedback. This is the one place I'm going to have to teach you a little more science, because feedback is absolutely the heart of where the climate models and catastrophic forecasts go wrong. And so we're going to talk about feedback, and instead of using these charts, I'm going to use props. You can tell from these expensive props that I'm obviously funded by the oil, coal, utility cabal. But anyway, I'm going to put this ball on the bottom of this bowl and start the ball at rest. Now I'm going to give it a good tap. The ball rolls around and around. It's eventually going to come to a stop really close to where it started, because the sides of the bowl and gravity tend to neutralize what input I gave it. Even if I give the ball a good shove this way or that way or that way, everything conspires to bring it back to where it started, to counteract the input I put into the system. That's an analogy for negative feedback. Negative feedback is where a process acts to partially counteract any disturbance to its equilibrium. It's like pushing a car uphill with the brakes on. When I shove a system dominated by negative feedback, the system shoves back. As a result, I might not have as much effect on the process as I thought I would before I started. The opposite of this is positive feedback. Positive feedback is way more dramatic. I'm going to turn the bowl upside down now and balance the ball on its top. In the previous case, even when I gave the ball a very solid tap, it ended up about where it started. Now I'll give this ball the tiniest little nudge. I barely touched it, and the ball is now 15 feet away. This is a good analogy for positive feedback. The system amplified my tiny input and caused that ball to roll a long way away. Small inputs can lead to very large changes in the system, dominated by positive feedback. This is how the feedback multiplier effect works. Let's do an example for positive feedback. Let's presume an initial input or disturbance to the system. This could be some initial CO2-driven warming, or it could be the tap on the golf ball. We're going to assume that the first order feedback from such disturbance is a positive 50% of the initial input. That means the first feedback adds an additional 50% to that initial tap. But there's feedback operating on the first order feedback, so we get a second order feedback equal to the 50% of the first feedback. And then we get a third order feedback equal to 50% of the second feedback, and so on into infinity. Fortunately, we don't have to count into infinity to solve for the final value. This whole infinite series reduces to the equation above, such that our 50% feedback, the final output of the system, is twice the input. In other words, a 50% positive feedback factor doubles the initial input. Any feedback factors of positive 100% or greater actually have even more dramatic effect. Those lead to runaway processes or tipping points. Note that this formula also works for negative feedbacks. For example, a 50% negative feedback results in a final value of 67% of the initial input. Coming back to our topic of global warming, warming from greenhouse gases alone, as we saw in the chart above with the blue no feedback line, is really quite small. Even a lot of added CO2 is only able to give a small nudge to the climate system, even by the estimates of alarmists. What really makes for the catastrophe are the assumptions in various climate models of enormous net positive feedbacks. Nearly every climate model you've ever heard of assumes that climate is the ball on top of the bowl, not the ball down inside the bowl. When Al Gore is talking about tipping points, think of the ball running far away from the bowl. He is talking about positive feedback so high that the equations literally go to infinity. A good way to think about it is to picture the Earth climate as your stalled car. Skeptics picture the climate as your car stalled in a parking lot, needing a lot of pushing and shoving to move it just a little ways. Climate modelers, however, assume the Earth is a car pushed precariously on the top of the hill. You give the slightest nudge, and it's going to start running downhill and accelerating just from that small nudge, and it's going to crash into smithereens at the bottom. And note that in this case, the key factor was not the nudge itself. It was the fact that the car was sitting precariously on the top of the hill so that the slightest force would start it running away. And that's positive feedback, and that's the assumption that these climate models are built from. So if you remember the 1 degree blue line above, that's not the climate modeler's final forecast. That's the nudge. That's from greenhouse gas theory alone. Here we see the actual forecast, the final forecast taking feedbacks into effect. Those forecasts vary from 3.5 degrees C by the end of the century, the IPCC base case, to 5.4 C, the IPCC high case, even as high as 10 degrees Celsius by folks such as Joe Romm. And so the answer to our question before about what we were missing with our original forecast of 1 degree Celsius from global warming is that feedback multiplies the forecast by 3 to 8 times in the climate models. So what are these feedbacks? I don't want to talk about all of them, but I'll give you an example. One thing that might surprise you if you only learn about climate from the major media is that CO2 is actually a very weak greenhouse gas. A stronger greenhouse gas is water vapor, and a much stronger greenhouse gas is methane. And so what all these climate models do is they assume that a small nudge of warming from CO2 then puts more water vapor in the air, which is a very big greenhouse gas, and more methane in the air, which is a big greenhouse gas. The extra water vapor results from higher evaporation rates as the world warms, and methane is theoretically released as certain Arctic tundra and frozen peat bogs thaw. The water and the methane in turn cause a lot more warming, and then you get the whole cycle repeated again and again, warming and warming and warming in a recursive manner. And even in this complexity, we're grossly oversimplifying certain assumptions, ignoring time delays, etc. But what you need to know for now is that catastrophic man-made global warming theory is actually a two-part theory. Greenhouse gases provide the nudge, and positive feedback creates most of the warming by multiplying the nudge many-fold. By the way, don't think that this is some weird skeptic's version of the theory. I don't believe I've strayed off the orthodoxy in any meaningful way in describing this two-part theory. But it's not well communicated, and there's perhaps a reason for this. Scientists and alarmists love to fixate on greenhouse gas theory, and they love to argue about greenhouse gas theory being settled science. And it's true that many, including a lot of skeptics, will grant that CO2 without feedbacks probably causes about a degree of warming for every doubling in CO2 concentration. This is the best understood part of the science, so it's the place they most want to defend. But recognize that 1 degree is not a catastrophe. We have seen now that the catastrophe results from the multiplier effect of CO2 from feedback. It's this theory of positive feedback, the theory that the climate is a car perched on the top of the mountain, ready to run away, that leads to the catastrophe. The catastrophe does not come from greenhouse gas theory. The catastrophe comes from a second independent theory that the Earth's climate and temperature system is dominated by very large net positive feedbacks. Just to finish off the alarmist case, the rise in temperatures are feared to cause all these different knock-on effects, from changing precipitation to droughts, melting ice, rising sea levels, species extinction, polar bears drown, there's more hurricanes, there's more tornadoes, there's more severe storms, bird migration patterns are disrupted, there's more tropical diseases, there's more acne, there's more suicides, and I kid you not, you can Google it, there's more prostitution, everything. Basically, anybody who writes a PhD thesis nowadays has to include global warming. If you're writing your thesis on ruby-throated hummingbirds, you're going to write about the effects of global warming on ruby-throated hummingbirds, because that's how you're going to get your funding. Okay, I've done enough for the alarmist case. If they want it presented better, they can debate me in public. Now I'm going to talk about the science of the skeptic case, because I don't think this gets communicated very well, and it's way too nuanced to survive a television soundbite. I'm going to ask a series of 5 questions about global warming. First, I'm going to ask if there has been any warming over the last century and a half. Then I'm going to ask if the warming is due to man-made CO2. And then I'm going to ask how much warming will there be in the future from CO2. And I'm going to ask what catastrophic effects we can expect to see, or perhaps are already seeing, from man-made global warming. And finally, we'll talk a little bit about CO2 abatement programs like the Cap and Trade Bill currently in Congress and the Copenhagen Treaty. Okay, first question, is the world warming? Yes. I'm not going to argue about it, there's no point. The early 19th century was the end of the Little Ice Age, perhaps the coldest period in the last 1,000 years and maybe longer. A warming trend in recovery from this frigid period is entirely to be expected. Again, I think a lot of skeptics waste their time arguing about stuff that there's no point in arguing about. This graph shows the temperature history going back into the 19th century. The source is from the East Anglia Climate Research Unit in the Hadley Center, a totally normal source of data, though recently under fire as a result of numerous improprieties in the CRU scientific process. But since this presentation predated the now famous email release, I will largely ignore this topic in the rest of the lecture. The data source switches over on the right to the more modern satellite technology in the light blue. The orange line is the moving average. From it we see a trend of 0.6 to 0.8 C over this period, or about 1 degree Fahrenheit for the last century and a half. But while I acknowledge the likelihood of some past warming, there are a couple of twists to our tale that are not well publicized. Before I get into these, I encourage you to try an interesting exercise. Go onto Google and search for global warming accelerating, and you'll get over 1 million articles that say global warming is accelerating. As recently as December of 2009, UN Secretary General Ban Ki-moon said, quote, "Climate change is happening much, much faster than we realized, and we human beings are the primary cause," quote unquote. So let's look at the tail of the tape. Here is a zoom in the last 10 to 15 years of the previous temperature chart. I have not put a trend line on it because currently we're in the midst of a trend line war where various people are taking this chart and cherry picking end dates to show the trend they desire. But I think visually you can tell that 1, you can't see any real acceleration here, and 2, it sure looks awfully flat for the last 8 or 9 or even 12 years. And that is not something, no matter what climate scientists say, that their models predicted. One scientist famously said in the CRU emails, quote, "Where the heck is the global warming? The fact is that we can't account for the lack of warming at the moment, and it's a travesty that we can't," unquote. The oceans are a particularly good place to look for global warming. Land does not hold on to heat very well, so most of the heat the Earth's surface retains is buried in the oceans. They are the heat reservoirs for the Earth's surface, and so measuring ocean temperature is critical. Over the last 10 years, we have launched new satellites to perform these measurements better. We have also launched some really cool Argo floating buoys that drift around the world measuring ocean conditions and from time to time sending a probe as deep as 800 meters to sample ocean temperatures at various depths. This chart shows what these new technologies tell us about ocean temperatures over 8 years or so that they've been in operation. Again, we can play endpoint games, but it's difficult to find a warming trend in this data. I'm going to take a little bit of an aside here on temperature measurement because I promised some folks that I would talk about 2 things. One is the role of amateurs in climate, because I'm an amateur, and the other is the role that kids can play since I'm presenting at my kids' school. Forget about the colors in this chart for a second. This is a map of the U.S. Historical Climate Network, and each cross is an official temperature station in the U.S. HCN. It's basically the 1,000+ U.S. stations that roll up into the global temperature number I showed you before. And a lot of these are actually still operated by amateurs. I've been to some of them. They're actually in their backyards. For decades, most of our climate data came from amateurs who would go out and they would read the temperature and read the anemometer and read the rain gauge and write down the measurements and turn them into the Weather Service. And that's how we would monitor a lot of climate. Today, most of these have been automated, but quite a few are still in people's backyards. So there's always been a strong role for amateurs, and over the last year or two there has been an amateur effort to document the condition of these weather stations, led by a guy named Anthony Watts up in California. He is a meteorologist who went out to visit a few climate stations and concluded that the installations were terrible. They were not at all what the standards book says the temperature installation should look like. One has to be careful how one sets up temperature stations to avoid biases. For example, one would prefer to have the measurement point in an open field than, say, on a patch of black asphalt or near a metal building that might reflect or radiate heat into the thermometer. So let's go back to this chart. The colors represent how much a certain area of the country has warmed or cooled over the past 100 years according to the US HCN database. And for some reason, Tucson had the most measured warming of any place in the country. I'd already talked to Anthony Watts about his project to document station conditions, so I volunteered to start by driving a couple hours down to Tucson to check the site out. Was this a quality site, or were there biases that might explain the large reported warming? This is probably the most famous photograph I will ever take because it's all over the internet. It has been in many presentations all around the world. I still see it all the time in the oddest places. It is the USHCN official temperature station in Tucson, located on the campus of the University of Arizona. I think even those inexperienced with the topic get it immediately when looking at this picture. This is a terrible location for a temperature station. Weather monitoring stations are supposed to be in natural ground, not near buildings, not near anything that could raise the temperature of the device or bias the temperatures from what would be a natural temperature. You can see it sitting in an asphalt parking lot and surrounded by buildings. The asphalt of the parking lot absorbs heat during the day and releases it at night, warming the surroundings higher than the ambient temperature. In addition, the buildings block the wind that might help mix the air. The ability of man-made structures and paving and machinery to raise temperatures in cities is called the urban heat island effect. Most of you who live in cities probably see the effects of the urban heat island every night on the news. The weather forecast will give you the evening forecast as something like low of 59 in the city, 52 in the outlying areas. Unless you live in certain parts of Hawaii, a few miles drive does not generally take you to a different climate zone. The difference in these forecasts is the urban heat island effect at work. We can travel back in time to 1900 and see what this site looked like at the turn of the century. Remember that Arizona at the time was still a territory. It wouldn't even become a state for 12 years. And we see the area was entirely rural. This is Old Main, the original building of the University of Arizona campus, not far from the location of the current temperature station. No cars, no asphalt, no buildings. And so it has gone from this to this. So are we measuring global warming, or are we measuring the growth of Tucson? After surveying the Tucson location, my son and I did a series of surveys of other Arizona locations for a 7th grade science fair project. By the way, this is a great science fair project, and the online instructions at Watch site make it really easy to do. You can see the types of installations we found. In short, they are all poorly sited stations. We found a metal building that reflected heat on one temperature station, the little white beehive-like cylinder on the pole. We found one next to an air conditioning exhaust between two closely spaced buildings, and one in an asphalt parking lot right up against the maintenance building of a hospital. These are terrible locations that are full of biases. The NCDC handbook indicates that stations with siting problems like these likely have errors and biases as large as 5 degrees Celsius. Which raises the obvious question, how can we reliably measure a warming signal we think might be on the order of a ½ degree Celsius with an instrument that has 5 degrees Celsius error? The signal-to-noise ratio here is terrible. In 8th grade, my son did a second science fair project related to these issues of temperature measurement. We had heard from a climate alarmist that the urban heat island effect either didn't exist or was irrelevant to temperature measurement, so we attempted to measure the Phoenix urban heat island. We strapped a PVC tube to the top of the family truckster and put a small, inexpensive temperature measurement device into the tube. The device is accurate to within about 1/10 degree Fahrenheit and can be connected to a computer to dump its data. We also carried in the car a GPS receiver that could log the data for later download to our computer. After synchronizing the clocks in the two devices, we used the timestamps to match temperatures to location. We began driving around Phoenix at night. First we started at the center of town and we drove north. Then we returned to the center and drove south. This is the data from the northbound trip. The temperature began at 52.5 degrees in the center of town. By the time we got to the outlying areas about 25 minutes later, the temperatures had dropped 7 degrees in that short drive. We wanted to make sure that the drop wouldn't be attributed to general cooling at night, so we drove the route backwards to average the temperatures and thus eliminate any background cooling trend. What we found was a 7-degree difference due to the urban heat island effect. We actually found an even larger distance driving south the next night. To wrap it back up, the professionals have done these same types of experiments too. This particular chart is from a study in California, but similar work has been done on a number of times. In California, they found that over the last 50 years, the urban thermometers showed a degree of warming, while the rural thermometers, in contrast, showed about 1/3 of a degree of warming. So does that mean that CO2 is somehow preferentially picking on cities? Or does that mean that maybe the big city thermometers are biased by the city growing around it, and that some of what we call global warming is in fact local urban heat island growth around measurement points? And so, the conclusion is that almost certainly there has been warming, though temperatures have been flat for the last 10 or 15 years. And past warming likely has been overstated due to biases in surface temperature record, and several studies estimating that as much as half of the warming in the surface temperature record may be due to uncorrected urban biases. So the world has warmed since the Little Ice Age ended in the early 19th century. Now I'm going to ask how much of that warming is from CO2. Here's an analogy I use a lot. Take your cell phone. If you have been using it, the battery case is probably warm. In fact, one can say it is settled science that the electronics in your phone produce heat. But does that mean cell phones are the primary driver of the temperature in your room? Probably not. The air conditioning system, the weather when the door is open, our body heat, all have a lot more to do with temperature changes than does your cell phone. I'm always amazed when strong man-made global warming advocates declare that their proof is complete once you admit that CO2 and other greenhouse gases can cause some warming. But the fact of some warming is not as important as its magnitude. We are looking at investing literally trillions of dollars on CO2 abatement because of a promised catastrophe, not some minor warming. So it matters whether outside the lab and in the complex climate system of the Earth, CO2 causes a trivial amount of warming or it causes a lot. So the question with CO2 boils down to this. Is it the cell phone warming the room by just a trivial and nearly undetectable amount? Or is it CO2 more like the room's thermostat, acting as a primary driver for temperatures? To put the question more in the parlance of climate science, is the climate system temperature sensitivity to CO2 large or is it small? I'm going to discuss three important arguments alarmists have made to try to prove that CO2 is a substantial rather than a trivial driver of global temperatures. The first of these three proofs of high climate sensitivity to CO2 was used by Al Gore in his movie. Gore is obviously much cooler than I am because if you see the movie Inconvenient Truth, he presented this chart spanning across 6 giant screens, which must be a pretty fun way to present. And this for a long time was the smoking gun of CO2 alarmism. Before I talk about what the chart means, I want to discuss how it was created. We want to look at climate thousands, even hundreds of thousands of years ago. But obviously the Geico caveman didn't have a thermometer, and he wasn't writing temperatures down on his cave wall. So we have to find a different way of taking temperatures without actually using thermometers. And the way we do it is to look for natural processes that layer themselves. An obvious example is a tree. Trees have layers. They're called rings, 1 ring per year. You can match each tree ring to a particular year. And so if tree rings somehow had some information in them about climate, we can match this information to a particular year. For example, scientists posit that tree rings are wider in warmer years and narrower in cooler years. Actually, it's more complicated than this, looking at something called late season growth, but you get the concept is the same. The tree ring data is called a proxy for temperature. Another such potential proxy is sediments at the bottom of a lake. Every year, runoff and rivers wash new sediments into the lake. One might look at these sediments and their contents, again matching layers to years, to derive information about plant growth or pollen types, and perhaps form a hypothesis of what the climate was doing in those years. Stalactites and stalagmites are another example of layering that sometimes contains climate data. Ditto for peat bogs. But the research we first used was ice. Ice in Greenland and Antarctica, which are places where ice, once it's laid down, it seldom melts. One can actually drill through the ice, just like oil companies do in potential oil-bearing strata, and take core samples. Like with tree rings, one can match different layers of the ice to different time periods. And from samples taken from these layers, researchers can infer the regional temperatures when the ice was laid down. They do this by measuring the ratio of certain oxygen isotopes in the ice. They can also measure the composition of microscopic traces of trapped air in the ice to figure out how much CO2 was in the atmosphere when the ice was formed. This is what was done in the chart above. And just looking at the chart, one has to say, wow, as Al Gore says, these two lines fit together. It's just unbelievable. You almost never see independent variables correlate this closely. This looks like CO2 is the main thermostat of the climate system, not just the irrelevant cell phone. This was a smoking gun. But scientists have gotten better at doing this analysis. While we really would like to take and sample annual layers from the ice, we just aren't that good, and besides, who wants to take 600,000 samples? But over time, scientists have been able to take finer and finer slices. And one of the things researchers found as they took finer and finer slices is that these two curves weren't exactly matched. And in fact, the temperature was rising on average 800 years before the CO2 was rising. Now that obviously posed a causality problem. It's like having a body hit the floor and then 2 minutes later the suspect fires his gun. It's hard to call the suspect a murderer when his gunshot occurred after the victim died. As you can imagine, we don't really treat this analysis as a proof anymore of high climate sensitivity to CO2. And I suspect that Gore knew it too, even at the time of his movie. Because he doesn't just say, case closed QED. You have to watch his words, but he says something like, well, the relationship is complicated, but these lines move together. Well, that's a really wimpy way to state your case, particularly given how devastating the correlation seems to be in this chart. What most scientists currently think happened is that rising temperatures actually cause rising CO2 levels rather than the other way around. The oceans actually hold far more CO2 than the air does. The oceans contain substantial dissolved CO2, but their ability to keep CO2 dissolved reduces as the water gets warmer. And so when the oceans heat up, they release CO2 in the air. And that is what has probably happened in this chart. Temperatures rise and oceans heat up, releasing CO2 in the atmosphere, which causes the concentrations to rise. Okay, so much for ice cores. Let's look at proof number 2 that CO2 is the primary driver of the warming we're seeing. This analysis is best known as the hockey stick, originally from Michael Mann. To understand this analysis, it is first useful to review some history. Back in our naive days, before we knew that CO2 was the cause of everything, the IPCC itself produced this analysis of temperatures over the last 1,000 years. You can see what we call the medieval warm period, though we think now this has it dated a little late. And you can see a cold period called the Little Ice Age in the 17th and 18th centuries. And you can see the temperatures today higher than they were a century ago, but not outside the range of the last 1,000 years, and likely still cooler than they were in the Middle Ages. In fact, it was the end of the medieval warm period that caused a whole series of cold weather and crop failures, which led to famines which many historians say may have weakened the population, making it more susceptible to the Black Death of the mid-14th century. So it was also during this period of time that the Vikings colonized Greenland, which they did not call glacier cold uninhabitable land, they called it Greenland. Similarly, we have other historical records in the medieval warm period pointing to a time period potentially warmer than it is today, including records of vineyards in the UK growing grapes where it is too cold to grow them today. Similarly, we have a lot of historical evidence for the Little Ice Age as well. It actually corresponds to the solar phenomenon called the Maunder minimum, a time when sunspot activity was very low, indicating a relatively dormant period in the sun's output. We have narratives of skating on the Dutch canals and ice fairs on the Thames. Towards the end of this period, we have Washington's terrible winter in Valley Forge and Napoleon's losing battle with the Russian winter in 1812. But it's hard to create a panic about warming when temperatures today are below historical levels when humanity demonstrably prospered, which is why a small cadre of climate researchers set out to eliminate the medieval warm period from the historical record. This is the data series from Michael Mann that Al Gore showed in his movie, though he incorrectly attributed it as Dr. Thompson's thermometer. Apparently he or his staff pulled the wrong chart out of a published journal for the movie. This same analysis was the centerpiece of the IPCC third assessment. To create this chart, Michael Mann and his team used tree ring data to reconstruct temperatures over the last 1,000 years. He used about 400 or so different tree ring samples or proxy series. From this analysis he concluded, hey, there's no medieval warm period, there's no Little Ice Age, and temperatures have been astoundingly constant for 1,000 years until we started burning fossil fuels, and then temperatures took off in an unprecedented manner. And if this were the true picture, one would say, gee, maybe we are doing something unusual to the climate. Maybe these climate alarmists have a point, because it surely looks like the Earth's temperatures were awfully stable until we started burning stuff. The whole issue of the hockey stick has resurfaced again of late with the release of the internal emails from the CRU at East Anglia University. These emails seem to point to a range of either sloppiness or outright malfeasance in temperature reconstructions like this hockey stick. So much so that a number of prominent alarmists have actually declared that a hockey stick doesn't matter and never really was critical evidence, an odd claim since it was clearly the featured centerpiece analysis of the third IPCC assessment, was given significant coverage in the fourth assessment as well as in Al Gore's movie. So it is for no other reason than to open a window in the scientific process. I will give this and subsequent reconstructions a bit of attention. The first issue that comes up over and over in evaluating these mini tree ring studies like Michael Mann's is one of statistical method. I've had the opportunity to visually inspect over 1,000 proxy series, and it's hard to escape the conclusion that there are very, very few hockey stick shaped curves in the individual proxy data, maybe 5 in every 100, and that's generous. So it is no real surprise that if you take Michael Mann's original 450 tree ring proxies and you just graph the simple mean, it looks like the top graph. The average output from the proxy series just looks like random noise, certainly with no discernible hockey stick trend. An experienced statistician but climate amateur named Steve McIntyre started looking into the hockey stick years ago because he couldn't understand what statistical methods Mann was using to get hockey stick averages from raw data that didn't seem to contain hockey stick shaped series. And what McIntyre eventually demonstrated was that Mann had created an algorithm that essentially mathematically cherry-picked hockey stick shaped curves in the data and emphasized them with large weights in the final roll-up. So much so that McIntyre was able to feed Mann's algorithm randomly generated proxy series, essentially noise, and obtain hockey stick shaped results. At the end of the day, trees make really bad thermometers. Sure, they grow more or less rapidly depending on the temperature, but they can also change growth rates based on precipitation, changing soil chemistry, and even changing CO2 in the atmosphere. Further, the relationship between growth and temperature may not be linear and may even change over time. It turns out that a lot of trees Mann used are actually fertilized by CO2. That means that they grow faster when there's more CO2 in the air. So have his trees grown faster over the last 100 years because they were warmer or because they were being fertilized by increases in CO2? Is he measuring temperature or CO2 concentrations? Many of you may have heard the reference to hiding the decline from the CRU email scandal. I will use a nice graphic from the Daily Mail Online to illustrate an example of one such obfuscation. The chart in question actually takes advantage of two graphical tricks to exaggerate the hockey stick shape of the curve and hide data that does not support the author's conclusions. The top chart shows three proxy series, including one by Michael Mann and one by Keith Briffa, as they were reported on the cover of a key climate report. The three proxy series are in pink, green, and blue, and the instrumental temperature record is overlaid in red. The first trick is the big uptick in the hockey stick does not come from the proxy data, but from the overlaid instrumental data. Sure, these two data sources seem to match really closely between 1900 and 1950, but that is because they are forced to match by their authors. This is the calibration period where the proxy series coefficients are set. However, once the calibration period is over, one can see the instrumental records and the proxy series values immediately diverge. The best analogy I can offer is that the proxies are a dog on a leash until 1950, so it is no surprise they stay close to their master. But the real test is what happens when the leash is taken off, and in the case of the proxy series, they quickly wander far away. The proxies don't show a steep decline during 1950 to 2000 supposedly anthropogenic period. This does not mean, of course, that temperatures have not risen over the last 50 years just because the tree rings say they have not. The point, however, is that if the proxies are not following the current uptick in temperature, then they may well not have followed upticks in the past, casting doubt on the conclusion that the proxies somehow prove temperatures have been flat and stable for 1,000 years. Again, further evidence that trees make bad thermometers. The second trick is perhaps more blatant and less ethical. It is illustrated on the lower right. For a reason never explained in any document in which this chart was included, the green line, Keith Briffa series, was cut off around 1960. The reconstructed Briffa data above shows that this was pretty clearly done to hide a sharp decline in the proxy data. Again, the proxy data should closely follow actual temperatures up to about 1950, as this was the period that they're on the leash. But once let off the leash, they quickly go into the exact opposite direction as the instrumental record. While this may in part be because the instrumental record is exaggerated in some of the ways we discussed previously, the main reason for this is again that the tree rings and other such data series do not appear to be very reliable proxies for temperature. If they fail so miserably in measuring temperatures that we have a pretty good handle on today, how can we trust them to be correct for temperatures in 1400? And this is the problem that scientists were trying to hide. I probably have already taken more time than I should on these reconstructions, but I can't resist one more example, again from Michael Mann, this time from more recent study. Here is a proxy series based on layers of lake settlements in Finland. This is how the proxy works. In warmer years, more things grow, and more organic matter can be found in a particular layer of sediment. This organic matter reduces the density of the sediment, so the lower the density of the year's layer, the higher the organic matter, and therefore the higher the implied temperature. In this series you can see a medieval warm period in yellow with some crazy cold data for the last 100 years. We might expect from an initial inspection of the data that unless there is something climatically anomalous about Finland, this might not be very good proxy data. And in fact, the researchers who originally gathered this data determined that the last 100 years of data were probably corrupted by man-made agriculture, deforestation, and disturbance of the sediments over the last century. In other words, the last 100 years of data were meaningless. So enter Michael Mann. Climatologists putting together these studies claim that they do not cherry-pick the proxy series that give the answer they want, but the fact is that despite there being well over 1,000 proxy series from various studies, the same 20 or 30 get used over and over again, and what these have in common is that they reliably produce hockey stick results. When Mann approached these Tiljander settlement series, he did two things. First, he kept the data known to be corrupted from the last century. And then his algorithm flipped the chart upside down and used the proxy in reverse. So now he has a series with a medieval cool period and an incredible hockey stick shaped warming in the last century. He basically used this upside down Tiljander sediments 4 times to create his newest hockey stick. If you leave these 4 series out of the numbers, and if you remove some strip bark bristlecone pine tree rings from Southern California that are hotly contested as a reliable proxy, the hockey stick, which is shown on the left in his original analysis, goes away on the right. In fact, you get a chart very similar to the one we started with, showing a medieval warm period and a little ice age, and temperatures today any higher than they were in the Middle Ages. So a combination of cherry-picking, questionable statistical practices, and outright data abuse produce hockey sticks. Several folks have tried to step back from the Mann hockey team approach and to use a more fair selection of less controversial proxies. 2 such researchers are Moberg, who is generally considered a strong global warming supporter, and Lowell, who is more of a skeptic. And lo and behold, it comes right back to where we started. We get the medieval warm period around 1000, we get a little ice age, and the temperature today is similar or even lower than those in the Middle Ages. So we're right back to where we were 20 years ago after a little 10-year diversion via the hockey stick. One last note, here in the Phoenix area is a Center for the Study of Carbon Dioxide and Global Change. They have a project where they catalog all the published proxy series, asking a simple question. Does the proxy show temperatures in the Middle Ages higher or lower than today, and by how much? We can see that the vast majority of these published proxies show that the medieval warm period was warmer than it is today by about 1 degree Fahrenheit. So much for the proxy studies as a proof of strong relationship between CO2 and warming. That's 2 down. Which brings us to the third argument for high climate sensitivity to CO2. Remember again that we are not talking about proof of CO2's ability to act as a greenhouse gas. We know that it acts as a greenhouse gas in the laboratory, and we know that in a meta sense that greenhouse gases warm the Earth. What we don't know is the amount of warming that results from incremental increases in CO2 concentration. Is it large or small? The third argument that the warming can be large from even small changes in concentration of CO2 comes from the IPCC 4th report and is really the dominant current argument for high sensitivities. As you may know, scientists have built computer models to try to evaluate the behavior of Earth's climate. None of these models even come close to modeling the complexities of the actual climate system. For example, most are unable to explain multi-decadal ocean cycles, much less longer-term climate cycles such as the descent into and out of the ice age. Nevertheless, climate scientists use their models to try to duplicate the actual temperature history of the last 15 years, and unsurprisingly, they failed to do so. Flawed models weren't able to reproduce past temperatures. Now, I might have said this leads to the conclusion that we don't have a good understanding of the climate and that our models are simplistic and flawed. However, climate scientists concluded something entirely different. They said, because our models can't duplicate the increases in global warming over the last 50 years of history, then these increases must be due to non-natural factors, i.e. due to CO2. The temperature increases since 1950, by their reckoning, couldn't have been natural because our climate models that are supposedly based on nature can't reproduce them. In effect, the entire theory that most of the late 20th century warming is caused by man-made CO2 is based on the deep scientific finding that, well, we can't think of anything else it could be. Dr. Richard Lindzen of MIT has a great quote, which I'll share in total. What was done was to take a large number of models that could not reasonably simulate known patterns of natural behavior, and he lists a number of ocean cycles, for example, claim that such models nonetheless accurately depict natural internal climate variability, and use the fact that these models could not replicate the warming episode from the mid-70s to the mid-90s to argue that forcing was necessary and that the forcings must have been due to man. Here's an illustration in graphical form of the logic from the 4th IPCC assessment. The black line is a highly smooth temperature history of the last 100 years, though exaggerated because they chose the peak year in 1998 as their endpoint. The blue band is what their models tell them would have happened without anthropogenic or man-made effects. As you can see, the models apparently projected that Earth would have cooled over the last 50 years without increased CO2 from man. The pink band is the output from their models after assumptions from CO2 increases are added. The conclusion they draw is that because the models are unable to match history considering only natural effects, but can emulate history when they include CO2, then CO2 must be causing the warming. I don't know how many of you are actually familiar with computer modeling, perhaps in the financial world, but this is incredible hubris. Give me a few hours and I can force any model to match history, to actually bet real money that such model results are correct in the future just because we have tweaked the model to match history is madness, a sure way to bankruptcy, which, come to think of it, we've seen quite a fair share of on Wall Street recently. Just to be specific, here is the temperature history we've been using. We've been talking about the IPCC's claim that it is impossible to explain temperature increases since 1950 by natural factors alone. But since temperatures were flat for the early part of this period, what we really mean is that climate scientists believe it is impossible to explain temperature increase from 1975 to 1998 by natural factors alone. This is the area I have circled in the chart, which we might call the so-called anthropogenic period. I'm going to show you 4 alternate explanations for the late 20th century warming, other than man-made CO2. But before I do that, I want to pose a fun little exercise that I think illustrates my point. Here are 2 graphs of global temperatures over a period of 50 years. Each graph has the same temperature and has the same time scale. In fact, they're both just cut and pasted from the same graph. One of these charts is from the period 1957 to 2008, a period in which the IPCC says the global temperature increases can't be natural but must be man-made. The other is from 1895 to 1946, a period with little man-made CO2 where temperature increases almost have to be natural. These 2 periods sure look the same to me. How can one of these historical temperature increases be natural, but the other supposedly so steep and fast that it can't be natural, when the 2 look nearly identical? Now, as promised, I'm going to show you 4 potential alternate explanations for measured warming in the surface temperature record since 1950, all of which are at least as plausible as man-made CO2. I'm not going to say that any of these is the one and only cause. Likely is all of these plus man-made CO2 plus other effects we don't even yet understand, interacting in an incredibly complex way. But I think they will show you how absurd it is to rely on imperfect climate models to tell us that CO2 is the only possible forcing that could have caused late 20th century warming. The first of our 4 alternatives I will offer is land use. We've already talked about man's land use changes. Remember my son and I measuring the Phoenix urban heat island effect as 6 to 10 degrees Fahrenheit of warming. Recent studies have shown that nearly all of man's land use changes tend to cause warming, from building cities to tearing down forests for agriculture. This particular chart is from a recent study that claimed that most of the warming we have seen in the United States for the last 50 years could be explained by land use changes alone. So changing land use is one possible explanation of recent warming. Here's number 2, recovery from the Little Ice Age. We talked about the Little Ice Age a bit already, the several hundred-year, very cool period in the 17th and 18th centuries. Remember the ice core analysis that Al Gore showed over 600,000 years? In this chart, we're zooming in on the last 5,000 years or so of that same data. So here we are today. Here's the medieval warm period. Here's the Little Ice Age. The first thing you can see is a monotonic 1,000-year cycle of warm and cold in the context of which recent warming seems entirely consistent with history. The second thing you can see is that not only was the Little Ice Age cold, it is one of the 2 or 3 coldest periods in the last 5,000 years, or since the development of human civilization. In fact, the 17th and 18th centuries may have been the coldest sustained period civilized man has ever experienced. Coincidentally, it was right in the middle of this period that man invented the thermometer. I've always wondered how much of our perceptions of whether recent warming is unusual are colored by the fact that we began measuring temperatures at perhaps the coldest point in 5,000 years. So our second possible explanation is that we are just experiencing natural warming as part of recovery from the Little Ice Age. We're going to see more data to support this proposition later, as glacier retreat and sea level data since 1800 are much more easily explainable as a continuous recovery from the Little Ice Age rather than as a particularly recent phenomenon. The third partial explanation for some of the recent warming is the sun. It's frankly hilarious watching climate alarmists try to deny the sun has anything to do with climate variability. It's a fascinating spectacle. Over the second half of the century, when warming supposedly can't be explained by natural factors, and even by the IPCC charts, the world would supposedly have cooled without CO2, the sun was far stronger than in the first half of the century. One way to measure the activity level of the sun is to look at sunspots. When the sun is more active, we typically see more spots. This chart shows the sunspot count by month for the last century or so. Since sunspots follow an 11-year cycle, I've applied an 11-year moving average. I think it's pretty obvious that the sun has been substantially more active in the second half than the first half of the century. Now, there are a lot of reasons why this may not be enough activity to explain all the warming. Another measure of the sun's output, solar irradiance, only changes by a small percentage from the early to the late half of the century. Though there are some theories being tested right now explaining how solar output might be magnified by their effect on cosmic rays and cloud formation. Nevertheless, the sun is yet another likely contributor to recent warming. The fourth warming suspect is multi-decadal ocean cycles. This is an important flaw in most climate models, as nearly all admit that they don't include these ocean cycles in their algorithms. I'm going to oversimplify, but the oceans have circulation patterns that change every 20 or 30 years. In some of these cycles, the oceans act to bury surface heat in the deep oceans. In other cycles, the oceans tend to bring this heat back to the surface. I think it's fairly clear from looking at this chart, which uses the same surface temperature record we've been using in this presentation all along, overlaid with the warm and cold cycles in the Pacific Decadal Oscillation, or PDO. We can see a pretty strong correlation between the slope of the temperature curve and the phase of this one ocean cycle. Temperatures are falling to flat in the cool cycles, and they rise in the warm cycles, as in the key period from 1978 to 1998. Scientists say that the warming in this period has to be man-made because their models can't replicate the actual temperature trends, but the models leave out the PDO and other ocean cycles. I decided to try an experiment. I wanted to see if temperatures of the last 100 years could be explained by two natural factors: a linear rise in temperature, as we might expect from recovery from the Little Ice Age, and a sine wave representing a rhythmic ocean cycle. Note that neither of these shapes is what you would expect if anthropogenic CO2 was the main driver. You would see a rising curve of increasing slope that matches the rapid rise in CO2 output in the latter half of the century. So I took a 20 to 30 year cycle and combined it with a 0.04 degree per decade linear trend, as shown on the left. When I combined the two in orange and overlaid them on the temperature trend, you can see a pretty good fit. Now, this doesn't necessarily prove anything or have any physical meaning. Correlation can be accidental, a fact alarmists tend to have a selective memory of. But it does give the lie to the proposition there is no possible explanation of late 20th century warming other than CO2. Alarmists argue that the late 20th century represents a discontinuity from previous times where temperatures were driven by natural factors rather than CO2. But we can see from this chart it's perfectly possible to explain the recent temperature rise as being consistent with the same mechanics that dominated the early part of the century. Just to take it one step further and make it more real and less theoretical, here's the same analysis with the hypothetical sine wave replaced by actual values of the Pacific Decadal Oscillation, showing that the 20th century temperatures, both early and late, are explainable by a linear trend plus cyclic variation. Alarmists always say that skeptics don't offer any alternate explanations for recent warming. Well, we don't really have to, any more than I have to find an alternate explanation for how your socks went missing if you were to argue that invisible aliens were hiding in your closet and stealing them. But nevertheless, I've offered 4 alternatives, 4 potential natural effects that are all likely to have been partial contributors to warming in the critical period from 1978 to 1998. Add in CO2 and we get 5 contributors, and there probably are several more drivers in our complex climate system we don't even understand yet. The net result? CO2 from man has probably caused some of the historic warming, but more likely in the range of a couple tenths of a degree than the majority. So, now we can get to the really controversial part, the climate models. Remember this chart? These are the various forecasts of warming versus CO2 concentration that I showed earlier. The only thing I've changed is that I've shifted the axes a bit to give myself some extra room to extend these lines. As a reminder, this is the CO2 concentration range we expect to be at towards the end of the century. This is where we are now, and this is approximately where we started in the mid-19th century. There's one thing I didn't tell you about feedback the first time around. Here's an analogy for you. If I'm found on my kitchen floor with a knife in my back and my wife's standing there, the police are probably going to think of her first as a suspect. When a spouse is murdered, the police know that in a high percentage of cases, the other spouse did it. Experience has taught them some rules of thumb of what is and isn't probable. When a natural scientist looks at a natural process that is new to her, she is going to assume that the process is driven by negative feedback, especially if that process has been stable for hundreds of millions, even billions of years. Take climate. It has been fairly stable within certain bounds for millions of years. Just look at Michael Mann's hockey stick, where he says that temperatures have been dead flat for 1,000+ years. But this hypothesis of incredible stability is hard to square with the positive feedback hypothesis we discussed before, the hypothesis that the climate is a car perched on the top of a hill, needing only a small nudge for it to roll out of control. The strong positive feedback case, and in particular the tipping point phenomena that alarmists are always talking about in the news, make no sense. They defy any intuition a natural scientist might bring to a complex process. Long-term stable processes are not balanced on the top of a mountain where they can be tipped over the edge, or else they would have already been tipped over the edge long ago. Something would have sent that car down the mountain millions of years ago if it was really so precarious. The same is true with climate. So the natural scientist tends to assume negative feedback dominates most stable natural processes. Of course, we cannot just rest on this assumption. There are natural processes dominated by positive feedback, though typically not as strong as the feedback assumed by climate models. And there are a few spectacular processes that have tipping points and runaway feedback. Nuclear fission and atomic bombs is an example. I will deal directly with a couple of the larger positive feedbacks, and then try to offer a more elegant approach to get a handle on the net of all the positive feedbacks. The most important feedback factor, positive or negative, is moisture in the air, and its effect is both critical and poorly understood. Everyone agrees that warmer weather puts more moisture in the air, but does it show up as increased humidity, in high clouds, or in low clouds? Some of these may have positive feedback effects, some negative. Most all of the climate models assume that as the world warms, the relative humidity stays constant. Relative humidity is a measure of how much water vapor is in the air compared to how much water the air could contain at a given temperature and pressure. And that carrying capacity increases as the air gets warmer, meaning that warming with a constant relative humidity results in an increase in total water vapor in the atmosphere. It turns out, though, that as we have warmed over the last 50 or 60 years, relative humidity at most levels of the atmosphere has actually fallen off, so that models are actually wrong here. They're overestimating the increase in water vapor from rising temperatures, and thus overestimating the feedbacks in total warming. The other positive feedback effect I want to discuss briefly is methane. Methane is the hot talking point in the catastrophist camp right now. Just do a Google search, and you will see all kinds of articles about man-made warming causing methane to be released from melting Arctic tundra, which in turn has warming effect as methane is a much stronger greenhouse gas than CO2. The alarmists are all saying that methane release is accelerating and increasing faster than ever due to man. But this is simply not true. Methane has been increasing true over the last decades, but in fact the rate of change is actually decreasing, not accelerating. It is doing exactly the opposite of what we might expect were the methane positive feedback theory correct. But I said I had a better and more elegant way of getting at feedbacks in the climate sensitivity to CO2. The key is that if certain sensitivity and feedback levels exist going forwards in models, it has to exist backwards in history. Physics that apply in 2050 have got to apply in 1850 as well. If we have strong positive feedback in the future, it had to exist in the past as well. Since we have been measuring CO2 and temperature, however imperfectly, for a century and a half or so, we can extend these forecasts backwards into the past and see how well they explain past warming. We can ask, to believe this 10-degree forecast, what do we have to believe about past warming? And as you can see, we would have to believe that we've already seen 4 degrees Celsius of warming to be consistent with the same assumptions that drive a 10 degrees C forecast. Of course, there's probably a time delay, maybe 10 or 15 years, but this changes the answer only a small amount, by a few tenths. We still find ourselves in the position to support high positive feedback forecasts of having to believe there have been levels of warming way beyond what we have actually observed. Remember I showed you that we had seen perhaps 0.6 C of warming over the last century, and even that may have been exaggerated by measurement biases. And that 0.6 C is for all warming effects combined, so the warming from CO2 is only a portion of that number. So we might expect that the warming of CO2 historically with all these other effects was maybe a couple of tenths of a degree. That means the actual sensitivity curve should go through a point above here, which would put us in the negative feedback zone, which is, by the way, exactly where natural scientists would assume the process operated and would imply a total warming from man-made CO2 over the next 100 years of less than 1 degree C. So the amount of warming we've seen historically is consistent with negative, not positive feedback. But climate scientists say all the time that their models accurately describe past warming. To some extent, this means that they have managed to tweak and tune their models to spit out something like 20th century temperature profile. I was a financial and economic modeler for years, and a typical technique to use was what I called a plug variable, or an arbitrary variable whose value in each period is set to exactly match what one needs to make the model spit out the desired result. For climate modelers, one such plug variable is aerosols. Aerosols are solid and liquid particles in the atmosphere that can reflect solar radiation back into space and thus have a cooling effect on the Earth. They can be of natural or man-made origin. Man-made aerosols typically are byproducts of combustion and industrial activities and include things like sulfur dioxide and soot or black carbon. I'm actually not going to talk much about black carbon as the evidence is increasingly equivocal as to whether its net effect is cooling or warming. I personally believe that black carbon soot from Asia is in part responsible for recent summer melting events in the Arctic. So let's focus on sulfate aerosol concentrations on the left. Sulfate aerosols, unlike CO2, are short-lived, so that they tend to be concentrated downstream of the industrial areas that produce them. These aerosols are concentrated near parts of North America, Asia, and Europe, and cover perhaps 10% of the globe. The appeal of man-made aerosols as a plug figure is that, unlike CO2, we have a pretty good understanding of how to run an industrial economy while limiting the output of these aerosols. Countries like the US are already well on its way to reducing the emissions of these aerosols, and most countries will follow suit over the coming decades. So if these aerosols are assumed to have a large cooling effect today, they can help plug the gap between reality and the hypersensitive climate models, while still allowing catastrophic forecasts as the aerosols and their theoretical cooling effect go away in the future. The IPCC is the first to tell us that scientists really don't have a good handle on the magnitude of aerosol cooling. In a sense, this is a benefit to climate modelers, as it allows them to assume any cooling number they need to make their models backcast accurately. The most telling sign of this is that most modelers nowadays can produce results that look exactly like history, but they all have very different cooling rates for the aerosols. By some strange coincidence, every single modeler has assumed an aerosol cooling rate that is the exact value needed to make his or her model fit history. This is what I mean by a plug variable. But simple logic tells us that these assumptions almost have to be outlandish. Remember, high sensitivity assumptions were overstating past warming by 1 to 3 degrees Celsius, meaning that aerosols cover about 10% of the globe. We would have to see local cooling effects in those areas of about 10 to 30 C to actually produce a global 1 to 3 C cooling. And we can detect no real cooling whatsoever or substantial change in warming trend between aerosol-affected areas and those without aerosols. The other explanation for differences between forecasted and past warming is time delays and having heat hide in ways that don't show up in the surface temperature record. These are basically the same argument. The same oceans that may provide a dampening or slowing effect on warming after a change in radiative flux are the only locations where heat may be stored without it appearing in the surface temperature record. I mentioned earlier that scientists added new satellite and floating tools to better measure the heat content of oceans down to 800 meters. Since these tools were first put in place in 2003, we have not seen any meaningful increase in ocean heat content, shown in red here, as compared to the blue upwardly sloping line, which is the change in ocean heat content we might expect from the modeler's high feedback, high sensitivity assumptions were correct. If we really are seeing increased forcings from CO2 concentrations, the heat has to be going somewhere. It can't just go on holiday for a year or 2 or 10, but if we are not seeing it in the surface temperature record, and we're not seeing it in the ocean heat content, it's hard to imagine where it might be hiding. The final test I will discuss for these high-sensitivity climate models is to actually compare their forecast with actual temperatures after the forecast was made. This seems like an obvious test, but the IPCC has been pretty clever. They bring out a new 100-year forecast every 5 years and throw out the old one, such that we never really get to test more than the first couple years of a century-long projection. James Hansen, who is head of the NASA GISS and friend of Al Gore, and a consultant on his movie, stood before Congress with this chart in 1988. First, he pointed out how well his model matched historic temperatures and used that as proof of the accuracy of his modeling techniques. Of course, a lot of folks in the financial industry have led their investors off a cliff with a similar claim. Second, Dr. Hansen presented 3 forecasts based on a variety of CO2 emission scenarios from low to high emissions. As it turns out, actual emissions have actually exceeded even his high emission case, scenario A, so I have used that one for comparison. So we take his forecast and we find it completely falls apart practically from the first day after his presentation. Current temperatures are not even close to those he predicted. He is off by a factor of 5 or more on temperature increase since his presentation to Congress. Again, the reason is simple. Yes, CO2 concentrations have an effect on world temperatures, but scientists like Hansen have grossly overestimating this effect, in particular because of crazy high assumptions about positive feedback. I and many skeptics don't deny that increased CO2 will have some incremental warming effect in the future, but we expect that effect to be at most a half a degree to 1 degree C over a century. Hansen told Congress we would see that in a decade. Okay, we now move to the effects of warming. When I first wrote this presentation, I wrote the future of warming. But since everyone at Copenhagen conference in 2009, for example, claimed that catastrophic man-made climate change was already devastating parts of the world, particularly in poorer countries, we're going to spend a bit of time trying to find this mythical beast called man-made climate change. As many of you have observed, global warming has been cleverly rebranded into climate change. One reason for this is that since we haven't seen any warming for the last 10 or more years, alarmists need a different term that allows them to duck this inconvenient fact when raising the alarm. I think most of you know this, but it is important to repeat. There is no way that CO2 can cause climate change without the intervening step of warming. I'm not saying that there's no way that Warren Meyer thinks this can happen. I mean that there is not anybody, even in the alarmist community, that has suggested any mechanism by which CO2 could cause climate change without the intermediate step of warming. In other words, if we don't see man-made warming, we can't see man-made climate change from CO2. By the way, we've already seen a number of ways man can affect the climate, such as land use, but in this case we're focusing on CO2. But somehow this simple fact is getting lost, and alarmists are crediting extreme events to CO2 despite a lack of warming for a decade, and even assigning the blame for events such as strong tornado years during periods when temperatures have actually been relatively cool. The trick they are undertaking is to seek out events at the tail ends of the normal distribution, highlight these extreme events, and then use their existence to claim that somehow the mean climate pattern is being moved. But in fact, there's little we can learn about changes in the mean from publicizing isolated events in the tails of the distribution. And we will see that in many cases, the phenomena that make the news, extreme weather of all sorts, are actually not occurring with increased frequency, though they may be reported with increasing frequency. One of my hobbies is to audit college-level history courses. I just finished one on the High Middle Ages, between 1000 and 1300 AD. Unlike many people's perception of the Middle Ages as a time of stagnation and poverty, the High Middle Ages were a time of prosperity and innovation and population growth sandwiched between demographic collapses of the early Middle Ages and of the 14th century famines and plagues. It was funny watching the professor try to deprogram students, telling them that contrary to what they hear in the news, historically warmth has been a harbinger of prosperity and growth, not disaster. In fact, probably the only time between 600 AD and perhaps 1500 AD that the European population increased for any sustained period was during the medieval warm period, which was likely at least as warm or warmer than the Earth is today. So let's zip through several of these quickly. A lot of this data will of necessity focus on the US, because this is one of the few areas of the world where there have been comprehensive weather monitoring for a long period of time. First, let's look at drought. As you can see, there's no trend. Droughts may get more TV coverage, lending to the sense of the public that they're more frequent, but there's no trend in the numbers. Ditto with wet weather. I remember a couple years ago we had spring flooding up in the Dakotas in the upper Midwest, and supposedly that was proof of man-made climate change. An odd conclusion to be sure, as the flooding resulted from the melting of higher than average winter snowfall. It makes no sense in the context of global warming, but if you're an alarmist you can still run with it now that the problem has been rebranded climate change instead of global warming. Just the other day I saw a quote from an activist that said that corn likes it cool, and therefore yields will fall as the world warms. To some extent, this harkens back to the old Paul Ehrlich starvation disaster PR machine of the 1970s. Never have so few who were so wrong so consistently got so much positive press. These guys, who include current Obama science advisor John Holdren, have accurately predicted about 20 of the last 0 crises. In fact, Holdren gets special bonus credit for being a global cooling alarmist before he was a global warming alarmist. Anyway, many of these Ehrlich disciples have found their way into prominent positions in the global warming movement, so it should be no surprise that they are yet again predicting starvation and that they are yet again wrong. Throughout recorded history, increased temperatures have corresponded to bumper harvests, while cooler weather has led to demographic disasters. And as you can see here, U.S. corn yields have increased substantially through the same periods that climate scientists claim we've seen substantial warming. Next up, hurricanes. As you may have heard, Katrina was supposedly caused by man-made global warming. In fact, there's actually a lawsuit going forward where some power and oil companies are getting sued for creating Katrina. The media links between Katrina and CO2 probably represent a low point in science journalism in the United States. I challenge anyone to devise an analysis that can separate natural Gulf Coast hurricanes, which have existed as long as man has occupied North America, with a man-made one. The problem with hurricane measurement is that we typically remember the ones that made landfall and did a lot of property damage. But these are just accidents, random luck as to the course of a particular hurricane. And our increasing investment in expensive houses and buildings on the coast nearly guarantees that current hurricanes do more damage than past hurricanes. But there is an unbiased way to measure the total strength of hurricanes, cyclones, and tropical storms. You can't just count their numbers. What you really want to do is to look at an integral that combines their number with their strength with their duration. Really duration at each strength level. That approach yields a number for total energy in the hurricanes from their birth to their death, a number called accumulated cyclonic energy. I would love to show you data for 100 years on this metric, but unfortunately it really doesn't exist. The best we can do to get a total picture is to start around 1979 when we have the right satellite coverage. And interestingly, in 2009 this metric hit not the highest, but the lowest point in the last 30 years that we've been measuring it. Recent hurricane and cyclonic activity is very, very low. You all saw that feature in the news, right? No, you didn't. Tornadoes are a similar story. I put this chart in because Al Gore talked about these numbers in his movie. If you look at tornado counts from 1950 to today on this chart, your reaction is likely to be, oh my God, there's a horrible upwards trend. If only Al Gore and his chart makers had looked at the government data site more carefully. If you go to this page, you will see a warning that reads effectively, be careful with this data, the trend is a result of measurement changes. Today we have Doppler radar, we have storm chasers, we have TV news, we have more population. In 1950 we had none of that stuff. The source where Al Gore took this data specifically warns that the trend in this chart on the left is not due to changes in underlying number of tornadoes, but a change in our ability to detect, track, and count tornadoes. The site suggests that if one was to look at trends, one should focus on the larger tornadoes, F3 and above, which were less likely to be missed or overlooked back in 1950. And you can see the trend with this improved metric. There is no trend, or if anything, it's down. So much for increasing tornadoes, and oh, by the way, so much for related claim that the average tornado intensity is somehow increasing. Interestingly, since this chart was made, we've had two anomalous years. The early part of 2008 was a strong tornado year, with far more tornadoes than average. 2009 has been one of the weakest tornado years in the last 30. 2008's high-level tornadoes made every news outlet, with giant headlines proclaiming the large number of tornadoes was directly attributable to global warming, despite the fact that early 2008 was one of the cooler periods in the last decade. How many of you have seen the stories this year that 2009 is a very weak tornado year? None of you, right? Okay, ice in the Arctic. We've all seen the scary pictures of melting ice and forlorn polar bears. And this report certainly is scary. It says that the Arctic Ocean is warming, icebergs are growing scarcer in some places, and the seals are finding the water too hot. Reports all point to a radical change in climate conditions and hitherto unheard of temperatures in the Arctic zone. Expeditions report that scarcely any ice has been met with as far north as 81 degrees 29 minutes. Great masses of ice have been replaced by moraines of earth and stones, while at many points well-known glaciers have entirely disappeared. And this is right from the U.S. Weather Bureau in 1922. Again with sea ice, we are stuck with satellite imagery, and therefore we are limited to the last 30 years, so our perspective is very narrow. But anecdotal evidence from ships seems to point to the fact that the Arctic was at least as warm in the 1930s, as evidenced by the previous report, but we don't have good observation evidence to prove it, though this ice core data from Greenland seems to indicate temperatures at least as warm as today at mid-century. In 2007, in October, our local newspaper, the Arizona Republic, proclaimed in a headline that the Arctic sea ice was at an all-time low. All-time, of course, in the Republic's eyes, apparently being 30 years, which is as long as we've been able to measure sea ice from satellites. Interestingly, though, on the exact same day on the other side of the world, the Antarctic sea ice hit a 30-year high. You saw that reported too, right? Yeah, neither did I. By the way, if you're worried about sea levels, the sea ice we're talking about in the Arctic and Antarctic is actually irrelevant. Just like melting ice in your glass of water, melting sea ice has no real effect on sea levels. It's melting land ice that affects sea levels, and 90% of that ice is in Antarctica, about 8% in Greenland, and the rest in miscellaneous other glaciers. So let's talk about glaciers. I told you back when we were discussing the Little Ice Age that we would come back to these glaciers. The increasing or decreasing size of glaciers is something that's actually more easily tracked by older technologies than the sea ice extent. So we have a longer data history on glacier lengths. We have geographers' measurements and maps of glaciers going back hundreds of years in some cases. We can see from this data that glaciers were growing through the 1700s, corresponding to the Little Ice Age. After the Little Ice Age ended, in the early 19th century, glaciers began to retreat, and they retreated steadily all the way from the early 1800s to today, though as this chart shows, the glacial retreat has perhaps slowed down in the last 50 years. To believe that the current retreat of glaciers is due mainly to man-made global warming, you have to believe that somewhere right here, say around 1950, some natural process that had been causing glaciers to melt over 100 years just halted. The natural process halted, and at the exact same time, man-made CO2 took over and kept glaciers retreating at the exact same pace. Or you could just apply Occam's razor and say that the entire 150-year trend has nothing to do with man and is a natural result of the recovery from the Little Ice Age. Here are two specific examples among the hundreds that underlie the trend I just showed you. On the left is a map of glaciers at Glacier Bay, Alaska. I've been up there and it's beautiful. This is where the front of the glacier was in 1794. This is where it was in 1860, and somewhere around that time we started burning a little bit of coal in London. Here it is in 1907, where we've added a little bit of CO2 in the atmosphere. So all of this preceding retreat happened by 1907, which was before most of the CO2 was put in the air. This is what happened between 1907 and today. A second example is shown on the right. Here's a famous glacier in Greenland that's often used as a case study because it has receded a fair amount over the last couple years. But it started receding way back in 1851, a time well before any substantial fossil fuel combustion. Again, glacier retreats are not a new phenomenon in the last 50 years, i.e. the man-made CO2 era. Glaciers have been retreating steadily for 150 to 200 years for reasons totally unrelated to man's burning of fossil fuels. So the retreat of glaciers correlates much better with the end of the Little Ice Age than it does with the beginning of serious fossil fuel consumption. And you can see the same thing with sea level. Sea level goes up for two reasons. One is melting ice, though that is not likely the most important factor. Probably more important to rising sea levels is the thermal expansion of water. When mercury gets warmer, it goes up in the thermometer. When water gets warmer, sea levels rise. By the way, according to the IPCC, all the fuss about Greenland melting is largely irrelevant. Ice melting in Greenland is projected to be largely offset by increased ice in Antarctica. It is the thermal expansion of oceans, not melting glaciers, that drives the IPCC sea level forecasts. Some of the data we have is suspect because it is from tide gauges where the land may be rising or falling and thus disturbing sea level measurement. But the data we have says that since the Little Ice Age, we have had nearly constant rate of sea level rise for 150 years. So the answer to the large extent as to why sea levels are rising 2 to 3 millimeters a year is not man-made CO2, but because sea levels have been rising at this pace for 150 years. We can see the rate of rise plotted on the left. Again, we see cyclical variations, interestingly enough, on about the same 11-year cycle as sunspots, but no real rising trend. If you saw Al Gore's movie, he said sea levels would rise 20 feet and implied this could well occur in the next 100 years. The IPCC is a bit more grounded, arguing that sea level rise will likely be closer to 12 to 18 inches over the next century, or about 3 millimeters a year, hardly different from the pace we have measured over the last century. Okay, we could go on with this all day. We could talk about how snow disappearance on Kilimanjaro is a phenomenon unrelated to global warming, how figures are cited for warming-related species extinction that have absolutely no evidence behind them, and how threats of tropical disease spread tend to be refuted by experts in immunology. But we could spend all day puncturing the myriad of silly, non-evidence-based scare stories surrounding global warming. I want to move now to conclude with a brief discussion of policy alternatives. When backed into a corner on their science, most alarmists will fall back on the precautionary principle. The precautionary principle supposedly says that when there is even a low probability of something catastrophic happening, we should spend near infinite amounts of money to prevent even this small chance. They claim that this principle is somehow established, but in fact, we never follow it in any public policy discussions. If we did, we'd be building space lasers to deflect meteors or invading aliens, or we'd be actively addressing a future Medicare bankruptcy rather than making it worse. And contrary to what our parents always told us, procrastination isn't actually always a bad strategy. We are gaining wealth and new technology capabilities at such a rapid clip that problems that seem overwhelming today can be much easier to fix in a decade or so. The question I frequently get is, Warren, you buy insurance, don't you? All we're asking is that governments of the world buy an insurance policy against catastrophic man-made climate change. And sure, I buy insurance, but if I had a $4,000 car, I wouldn't pay $6,000 a year for the insurance. And that's what you're buying with many of the current CO2 abatement proposals. You're paying $6,000 a year to insure against a $4,000 accident. We can argue, as I have for the past hour plus, whether man-made global warming will really have a substantial impact. I obviously believe that it will not. But I think it's beyond argument that trying to roll back CO2 production and fossil fuel consumption to 19th century levels is going to be expensive in terms of its outright costs, the reduction in economic growth, and the impingements on individual liberty, which are, by the way, considered all too seldomly. I find it terribly frustrating when folks like President Obama talk about such changes being inexpensive or even a net plus for the economy by creating green jobs. The mistakes he is making with his green jobs fallacy are beyond the scope of this presentation, but if you're interested, go onto Google and Google the broken windows fallacy. In short, obsoleting trillions of dollars of existing capital investment in energy infrastructure and then replacing it with more expensive and less reliable energy sources is not going to be a net benefit to the economy. Take the cap and trade bill currently in front of Congress. Its supporters have said that it won't be expensive. But this is not just naive, it is terribly disingenuous. They have to know that the bill must be expensive or it won't work. The whole theory of cap and trade is that by limiting carbon emissions, we will cause shortages and raise gas and electricity prices, which will in turn cause people to use less. To work, people have to change their behavior, and people are not going to change their energy use behavior unless the prices go up. And they have to go up a lot. In Europe, they have $8 to $9 a gallon gasoline. They have not come close to the targets these folks are talking about. We are talking about adding $10 or more to U.S. gas prices, when historically 30-cent increases have sent folks into a tizzy. Further, the cap and trade bill in Congress is, unsurprisingly for those who observe Congress much, a playground for special interests. Already numerous groups have special set-asides, exemptions, subsidies, benefits, etc. This group can only grow over time. Cap and trade is also a terribly regressive tax, hitting the poor the most. It hasn't worked in Europe. It's an accounting nightmare. This is a terrible insurance policy and it has expensive premiums and really doesn't prevent any risks. We have to go for some sort of legislation. Our Arizona Congressman Jeff Flake has proposed an alternative. He proposes a carbon tax on fuel, a tax which, frankly, may have to be quite high to reach the CO2 objectives that are being discussed. A carbon tax would tax fuels based on their carbon content, such as the natural gas would have a low tax and coal would have the highest tax. But to offset the financial damage this would cause to the economy, Flake proposed that whatever revenue accrues from the carbon tax be returned to the public in the form of a cut in payroll taxes. Those are the taxes that currently tax both you and your employer to the tune of about 8% of your paycheck. As a libertarian, I'm not much on any new taxes, but I'm fairly comfortable with substituting one regressive sales tax for another. In this case, replacing a regressive sales tax on labor with a regressive sales tax on fuel. Not only would this provide some sort of insurance policy against man-made climate change by reducing fossil fuel use, but it would also reduce the cost of labor, thus providing an incentive to increase employment. I want to conclude with one final point. I think 20 years from now, beyond the costs we've been talking about to pay for this cap and trade bill, environmentalists themselves, or at least conservationists, are going to look back and say that the global warming obsession was a disaster for the environmental movement because it sucked the oxygen out of any number of legitimate efforts to improve our world. Environmentalists have gone all in on global warming, but with all their chips on one bet, their attention has lagged virtually everywhere else. I'll give you two examples. One is from the Beijing Olympics. Did you see the air pollution in Beijing? It was terrible. People were wearing masks in the street. I tell you right now, we have no idea how to have combustion economically without producing CO2. But we have a very good idea how to economically have combustion and have a growing society without making our air unbreathable. But the full force of our attention with China is on CO2, not on the air quality for their citizens. The other example is ethanol. Ethanol has gotten huge subsidies from Congress in the name of reducing global warming. This has been Congress's solution of choice, and study after study shows that ethanol actually increases energy use, does nothing to reduce CO2, worsens land use, and raises food prices. In the Amazon, the number one reason for destruction of the rainforest over the last decade or so has been clearing land for ethanol crops, part of Brazil's alternative fuel program that has actually garnered a lot of praise. Somehow, what used to be our real environmental concerns, like preserving the Amazon and having breathable air, have been sacrificed in favor of altering trace concentrations of carbon dioxide by minuscule amounts. It's simply insane. Anyway, I hope you've enjoyed Catastrophe Denied, and I appreciate your time. I do this out of passion and for fun, not for profit. My hobby is totally self-funded. I'm always up for giving this presentation to groups of 30 to 300. I charge no speaking fees, but I do need to figure out a way to efficiently get to wherever you are because, again, I pay for all the expenses out of my own pocket. For more information, please visit my website at climate-skeptic.com, which is also a link where you can email me with questions or comments.